Selamat siang dan selamat datang di acara Taiwan Smart Disaster Prevention Webinar. Saya Jane yang akan menjadi MC Anda pada acara hari ini. Sebagai informasi, acara ini diselenggarakan oleh TAITRA, Taiwan External Trade Development Council, dan MOA, Biro Perdagangan Luar Negeri Taiwan. Latar belakangnya terselenggara acara ini adalah kondisi perubahan iklim yang cukup drastis dalam kurun waktu beberapa tahun terakhir, dan 83% dari semua bencana disebabkan oleh cuaca ekstrim dan iklim seperti banjir, gelombang panas, dan badai. Kita harus secara signifikan meningkatkan kapasitas dan investasi dalam cerdas iklim yang lebih memadai untuk pengurangan resiko dan kesiapsiagaan bencana. Perusahaan Taiwan telah menyelesaikan proyek sukses yang tak terhitung jumlahnya dalam industri pencegahan bencana cerdas di Taiwan dan di seluruh dunia. Mengintegrasikan teknologi seperti pengolahan air pintar, analisis cloud, jaringan nirkabel berbasis cloud, dan pengawasan bencana yang meningkatkan keamanan banyak kota dan membawa kesejahteraan bagi komunitas lokal. Kami yakin bahwa perusahaan Taiwan adalah mitra ideal Anda, dan kami dapat membantu Anda memberikan solusi yang Anda cari. Untuk memulai webinar ini, saya ingin mengundang Mr. Wu selaku Director of Strategic Marketing Department dari Taiwan External Trade Development Council TAITRA untuk membagikan wawasannya mengenai pencegahan bencana di Taiwan. Mari kita sambut Mr. Wu.
Distinguished guests and speakers from Taiwan's well-known solution providers, greetings from Taiwan External Trade Development Council, TAITRA. I would like to extend a warm welcome to everyone participating in today's webinar. In recent years, the shortage of water is under pressure from climate change, and 83% of all disasters were caused by extreme weather and climate-related events such as floods, storms, and heat waves. These disasters are already on the doorstep in every country around the world. We must significantly scale up investment in climate-smart actions that strengthens risk reduction and preparedness. We are confident that enterprises in Taiwan are your ideal partners, and we can help you deliver the solutions you are seeking for. Since Taiwan is highly exposed to natural disasters, Taiwanese enterprises have proven themselves as competent solution providers in smart disaster prevention industry. Integrating technologies such as smart water management, cloud analysis, cloud-based wireless network, and disaster surveillance systems. Companies in Taiwan have completed countless successful projects in Taiwan and all over the world. By providing solutions in smart disaster prevention and more fields, Taiwanese businesses have enhanced city safety and brought well-being to the local community. Lastly, I would like to give special thanks to all the guests who stay us online in Indonesia. Thank you for joining our webinar again. Hope you all enjoy the presentation and have deeper conversation with Taiwanese enterprises afterwards. Thank you.
Terima kasih banyak Mr. Wu atas presentasi Anda. Hari ini kami telah mengundang perwakilan 5 perusahaan dari Taiwan, yaitu yang pertama, Water Hazard Mitigation Center, Water Resources Agency MOA ROC. Yang kedua, Taiwan Water and Soil Instrumentation Inc. Yang ketiga, International Integrated System Inc. Yang keempat, ANA System. Dan yang terakhir, Material and Chemical Research Laboratories, Industrial Technology Research Institute Taiwan, yang akan membagikan informasi mengenai solusi-solusi inovatif mereka di bidang pencegahan bencana. Pertama, mari kita persilakan Mr. Huang dari Water Hazard Mitigation Center, Water Resources Agency MOA ROC, yang akan membahas mengenai solusi pencegahan bencana banjir di Taiwan. Mari kita sambut Mr. Huang.
Hello, my name is Chun Huang. On behalf of the Water Resources Agency of Taiwan, it's my pleasure to present Introduction to Smart Flood Prevention in Taiwan. First, I will introduce the water environment in Taiwan and the challenge we are facing. Natural disasters can be categorized into 4 major types: earthquake, typhoon, flood, and drought. According to the assessment report of World Bank, Taiwan suffers greatly from natural disasters. About 90% of the population is threatened by 2 or more types of disasters. Taiwan is a narrow island with a central mountain in the middle. When it rains, water flows rapidly to the sea due to steep slope of the riverbed. Compared with rivers in Europe and Southeast Asia, such as Colorado and the Mekong River, rivers in Taiwan are much steeper. Also, Taiwan's geology is very young and fragile, making it prone to flood and sediment disasters. Floods are often caused by typhoon, prolonged rain, and short-duration intense rainfall in Taiwan. On average, 3 to 5 typhoons hit Taiwan each year. Typhoon is our major water resource, but its high intensity and long duration also cause disasters sometimes. In 2009, Typhoon Morakot brought the world's record rainfall, resulting in serious loss of life and damage to properties. To mitigate the impact of extreme weather, in addition to the structural measures such as levee or detention pond, the regulation, runoff allocation, and outflow control under Water Act stipulates government and the private sector have responsibility to implement the mitigation project. In order to mitigate the impact of extreme events, which cannot be handled by structural measures and regulations, we have proposed the Smart Flood Prevention Project to enhance our flood prevention technology and operation. The project goals include precise disaster management to improve the efficiency and the performance of disaster prevention operation, and reducing loss and damage to society and quickly recovering to normal life. The introduction of our flood prevention management and technology can be divided into 4 parts, corresponding to 4 steps of flood prevention operation. The first is monitoring. Meteorological and hydrological monitoring include rainfall, river water level, and reservoir water level. Usually, we have to survey inundation depth after major floods. Before we develop flood sensor, we can only record the maximum inundation depth during floods by crest gauge or watermark on the wall. Compared with flood sensor, the information is insufficient without real-time depth. Now, based on IoT and LP1 technology, we have developed flood sensor, and 1,468 sensors have been installed in flood-prone areas until now. Everyone can find out where is flooding through app or website. Also, widespread CCTV help us be able to know the whole situation of flooding, and we are developing image recognition technique to automatically find where is flooding and estimate the inundation depth. Next, warning and notification. With forecast rainfall, various warning information can be derived, including inundation, river water level, and reservoir discharge warning. As to inundation warning, in addition to rainfall threshold value method, which is a black box model, and it's practically used in Taiwan, we are also developing forecast model, including near real-time hydrodynamic and AI models. The inundation data collected by numerous flood sensors can be used for model verification and calibration. The warning information will be delivered to the public through diverse channels, such as app, social media, SMS message, etc. The tragedy used to happen in Taiwan. 10 disabled elderly in a nursing home were soaked in water for 3 hours after an extreme heavy rain. Now, With accurate and timely warning, the elderly and disabled could be evacuated in advance. Finally, response. When flood disaster happens, we collect information from flood sensors, news media, volunteer, and people's report. With flood location and depth, the inundation area can be automatically estimated. In addition to pump stations, mobile pump is necessary to reduce peak flow when the rainfall exceeds designed capacity of drainage system. We deploy mobile pumps in flood-prone area before the storm comes. With sensors installed in the pumps, we can know the location, status, and the fuel level of each pump remotely. The government puts a lot of efforts to promote and establish community engagement for flood mitigation in flood-prone areas. 464 communities are engaged until now. People of the community will help themselves to set up the water gate, the flood barrier, and evacuate people when flood warning is issued. Control traffic during inundation, and clean up the environment to recover from the flood. Conventional water supply system usually does not function properly due to high turbidity during flood disasters. Also, people in the remote mountain areas may be isolated due to landslides. So we have developed an equipment which is easy to be carried and quickly assembled to provide clean water for the people in these areas. Emphasizing disaster preparedness over disaster relief and evacuation over other preparedness measures is the principle we always keep in our mind with the implementation of smart flood prevention project. A safe, livable, and resilient water environment could be achieved for the public. Thanks for your attention.
Terima kasih banyak Mr. Huang atas presentasi Anda. Selanjutnya mari kita sambut Mr. Roy Chuang dari Taiwan Water and Soil Instrumentation Inc. yang akan membahas mengenai sensor tingkat yang tepat untuk peringatan banjir bandang. Mari kita sambut Mr. Roy.
Good afternoon, ladies and gentlemen. My name is Roy Chuang, representing Taiwan Water Soil Instrumentation Inc. I'm presenting the subject of the right level sensors for flash water warning. Today we'll cover 13 subjects. Real-time accurate flood forecast wanted, more uncertainty of water level information, more uncertainty in flood forecast, less careful selected level sensors, more uncertainties on water level information, and more sites but less valuable information will cause more uncertainty for warning. The climate change caused the extreme climate and resulting flash flood in many regions, especially for community, which is of our concern. There are some potential issues and the means we have been identified, so there are some rooms for improvements. There are some limitations of water level sensors applications, such as pressure sensor and ultrasonic sensors. And water level sensor figures requires accuracy, reliable data, prompt response, and low power consumptions. And applications including the centralized integrated monitoring system, or regional watershed flood monitoring, or community prompt flood warning system. There are some improvements we have been identified as listed below. Here's a table of comparison. We can identify TWSI have more advantage in innovative systems. which is more easy for installation. The quality water information monitor requires quality monitoring data for the mega database, etc. And the features of a TWSI water level sensor is especially for triggering of the data sensing and response. And here is an example of CET float operated level sensors. Here is a sample of the installation at different locations. And here is a feature of a CET float operated level sensors with many advantages. Satisfactory requirements as listed want economical accuracy, simplicity, convenience, safety, and stability. It's suitable for installation in many places as listed. Here is an illustration of how it works. The increasing of the rising water level will wake up the system and promptly transmit data. Here's an example, especially for regional drainage monitoring, especially for community-based flood warning system. Our system can directly transmit warnings to individual household and local government agencies such as city government, fire department, and the police station for prompt response. In Taiwan, we have a strategy for runoff distribution and outflow control, which is very useful by using the TWSI innovative water level sensors. This is another example we can install at different location of the system. If we can simultaneously sense water and sediments at the same time, will be more efficient for monitoring and the early warnings. This is innovative product of TWSI, or we can achieve this goal. Here is an example of installation of the simultaneous sensory technology. We can use in the water channel in the pond, or in the channel in the ditch, or the sewers. Here's another sample of scouring and the siltation monitoring in the river system. For example, in Japan, we have one system installed. At the lower right part, we can see the blue lines are the result measured by conventional water level system. They are not continuous, but you can see the continuous rate curve line is a result generated from TWSI instrument. Meanwhile, we can report the riverbed level as shown in the bottom, so which is more effective data for analysis. Okay. This is for water. It can also be used for water channel scouring and siltation monitoring. TWSI is founded in 1979. It's been dedicated to research and development for water and soil resource management and problems, especially caused by flood. This including river, water channel, water conservation, water source management, water purification management, disaster early warnings such as flash flood or landslide. Our product, including precision sensors, digital wire transmission, smart remote monitoring, early warning system, and community-based smart monitoring panel. Thank you very much. And if you need further information, please visit our website at http://hycom.com.tw. Thank you very much.
Terima kasih Mr. Roy atas presentasi Anda. Selanjutnya mari kita persilakan Mr. Jerry Wang dari International Integrated System Inc. yang akan membahas mengenai mitigasi bencana cerdas, aplikasi Big Data, dan AIoT. Mari kita sambut Mr. Jerry Wang.
Good afternoon, ladies and gentlemen. My name is Jerry Wang from ISI Company. On behalf of ISI Company, in the next session, I would like to share the experience for Big Data and AIoT applications on smart disaster mitigation. The agenda today, there are 4 points. The first one is the overview for the smart disaster mitigation. And the second, we will introduce some applications and the scenarios and some case studies for you to understand how to apply the big data and the AIoT in disaster mitigation. And third, we will introduce our experience for very short paragraph. And the fourth, the last one, we have some conclusion for you. Okay, the first one is the smart disaster mitigation overview. I think in the previous sections, you already know what's smart disaster mitigations, but I will quickly review the ideas. The first one is, based on the UN reports, it shows that the disasters and the economic losses almost double in the last 20 years. So in that figure, you can see the economic loss and the recorded disaster events has significantly increased. And among those disasters, flood is the majority one, the major one. And actually, after 1,000 years, either Taiwan, United States, even Indonesia, we are still fighting with the flood. So how to apply the IT technology into the disaster mitigation to reduce the impact? These are important lessons we need to learn. Recent years, the smart city ideas is booming, and actually smart disaster mitigation is always ranked top 3 in the smart city concept. That is how to utilize the smart technology to enhance the quality, efficiency, and also reduce the impact of the disaster. So I think this is the ideas for the smart disaster mitigation. In the past 30 years in Taiwan, it's already accumulatedly developed a lot of disaster mitigation systems, like the Emergency Operations Center, Monitoring Center, and other systems. So based on those systems and the experience, actually, there is a same methodology and the framework we can refer to. This is the framework and the methodology and also the process for the smart disaster mitigation. In the left-hand side, the first one is to collect the data. That means how to collect the useful data. 2 kinds of data. One is from the sensors. We collect them, so that's what we call IoT. And second one is the external agencies information. So we want to connect those information from other agencies like the Weather Bureau or other agencies. So we integrate those data into our platform. Here we call the iDiamonds platform. That means the intelligent disaster, IoT and AI modeling, neural network, and decision support system. That's what we develop for our customer. So we use those data to do the analyze and also to confirm the status so that we can have the prediction or early warning for the decision making. So based on those information, we can do the decision making support so that the command center or the officer can make a decision easily based on the analyzed information. And the last one, of course, if we have the actions, we need to announce to the public, to the response team, emergency response team, and all the peoples. So to announce those information through the different media, TV, web, or now most useful one is the APP, is the last one. So this is the idea and the framework for the big data and AI, how big data and AI involved into smart disaster mitigation. So in the next 2 cases, I would like to use the same framework to introduce 2 case studies. The first one is what we call urban flood forecasting and the early warning. Because we mentioned flood is the major disaster we faced recently. Even in Taiwan, the climate change result a lot of floods. From 2009 to 2019, we are still suffering from the flood. Okay, and according or referring in terms of the disaster or the flood disaster mitigation, there are two parts we can focus. The first one, in left-hand side, you can see the river water level. Also, we call it like the external water for the city. And the right-hand side is the urban water level, means the inside or internal water for the city. The water outside from the river, actually the early warning system application has been developed very maturely. So currently, in 10 minutes, we can have the 72 hours, 3 days forecasting easily in the current system. So currently in Taiwan, we focus on the disaster mitigation, especially for the urban water level, that means the internal water level early warning system. And how to achieve that? There are different ideas. Currently, we use two kinds of model to provide the prediction and early warning. One is called the physical model, one is called the statistic model. The physical model is based on the physical relationship to describe the process and to do the prediction. So it's known as the white box model because how much water we have, how much water it flows to. So we can estimate and have the prediction for the disaster. The famous model like SWMM or SOBAC or 3DI, those are the famous model developed by United States, Netherlands, and different organizations. And the other one is called what we call the black box model. It's the statistical information. We use the mathematic algorithm to calculate, to summarize data and to calculate and get the rules for the prediction. Like the correlation analysis, regression, and envelope analysis. They are all the statistic kind model. In terms of to improve that, in our project, we introduced the big data and AI tools into the project. In the left-hand side, you can see the hydrology station and the facility. We collect the data either from the IoT device sensors or to connect the different agencies through the network. In the middle, the network level is either the low power WAN or Wi-Fi or even 5G now. Just transfer the signal to the system. After we integrate all the data, you can see we use the neural network model to calculate and to have the prediction and early warning information. You can see the next page. So the input information like the flood sensors, the external water monitoring, drainage monitoring, and the pumping station information combined with the weather information in the right-hand side and the radar information to the model. It's like a neural network model like this one. In the left-hand side, there's the input nodes. The right-hand side is the output nodes. So we use the neural network model set up or established on the TensorFlow, it's the open source package, to estimate. And we use the back propagation method to train the model well. So easily we say we use the historical data for training the model to get the more accurate data or accurate prediction. So this is our targets to go. And the second example is similar, but we focus on a more interactive way to do the disaster mitigation. This is the project in Tainan City, one of the major cities in Taiwan. The concept is how to increase or enhance the accurate and also the interactive between the system to the government. So we introduce the new water pumping and water flood sensors for two kinds of works. The first one is to enhance the real-time flood simulation and forecasting, so that we can do the 1 hour flood forecasting in 10 minutes, every 10 minutes. And for the 3 to 6 hour forecasting, we can update every 1 hour. So to realize that situation, actually we use the AI calculation or AI to support the decision making. The idea is that, the example is that if we move the mobile pumping station or mobile pump to the certain area or the selected area location, then it will show the next 1 hour, 3 hour, or 6 hour, or 12 hour simulation and prediction for the water level. And this information actually is dynamically connecting to the mobile pump and also the water gate and also the flood detention information. So either parameter changes, the simulation may change, but it provides the government, the officers, more dynamic and more straightforward information to make the decision. And not only to do the prediction and also the warning. From monitoring, warning, and the last one, we need to do some action. So how to connect to the contingency plan and actions is the last step we want to do. So the pre-planned SOP like this is usually prepared by government before the disaster occurs. Okay, so actually there are a lot of AI and big data example, but due to the time limitation, I cannot introduce everything. So the hydropower plant, the pumping station, and the groundwater management, we all use the big data and AI into the management way. Okay, and to us, to ISI company, where I'm from, actually we have more than 20 years experience for the disaster mitigation fields. Currently we have 1,000 people. We focus on public sector and also the smart city applications. And for the disaster mitigation reference, you can see we have more than 20 years experience and more than 100 projects experience in the past. Now we focus on the AI and big data applications with our customer. In the conclusion, today we don't have too much time to describe the technical part or the ideal part, but for the key success factors based on our experience, I would like to mention. The first one is the right person. You have to choose the right person, combining the domain knowledge and also the IT professionals. Because IT is just a tool, but not a product to use. It's not, you buy this product or you buy this software, you can solve the flood issue. No way. And the second one, the right tools. Yes, this is what I mentioned. Technologies are the tools only, but how to use that tools into the problem, that will be important. So what you need is not a product, not a technology, but a solution. And for the project and government promotion or implementation, always think big, start from small and scale up. Because ICT is a supporting system, but we need to lead, if we want to lead to the success, we need to work with the infrastructure improvement. So it conclude my presentation. We look forward to have you to marching for success in the future. Thank you.
Terima kasih Mr. Jerry Wang atas presentasi Anda pada hari ini. Para hadirin sekalian, saya ingin mengingatkan bahwa Anda dapat mengirimkan pertanyaan melalui QR Code yang tertera pada layar Anda. Para perwakilan perusahaan dari Taiwan akan menjawab pertanyaan Anda dalam beberapa hari ke depan. Presentasi berikutnya akan dibawakan oleh Mr. Richard Huang dari ANA System yang akan memaparkan mengenai solusi penanganan banjir ibu kota dan irigasi di suatu negara serta aplikasi AIoT praktis di Taiwan. Mari kita sambut Mr. Richard.
Hi everyone, I am the CTO of ANA System Incorporation, Dr. Richard Huang. Today, I am going to share some practical AIoT applications we deployed in Taiwan, including city flood and country irrigation management solutions. Before that, allow me to give a brief background of ANA System. ANA System was founded in 2002. In the past 19 years, we focus on developing IoT and AI-related technologies and applied them on smart cities, smart factories, and smart agriculture. We were awarded in 2012, 2017, and 2019 for advanced IoT cloud, flood management, and smart irrigation solutions. All the key technologies for an IoT total solution, including front-end devices to the back-end cloud systems, are developed on ANA System our own. We have integrated state-of-art LPWAN telecommunication technologies, such as 4G, NB-IoT, LoRaWAN, LTE Cat M1, and 5G. Traditionally, setting up an automatic water-level data acquisition station is costly and time-consuming. The picture demonstrates an old-fashioned composition of a water-level station, which including a data logger, 4G modem, charger, battery attester, solar panel, water level sensor, and a big enclosure. Unfortunately, the obsolete design is still widely used around the world. 5 years ago, we designed a full-functioned and highly compact IoT front-end device, Sense Mini. Except for the solar panel and sensor, we stuff every component in the previous slide in a small, waterproof, and strong industrial standard enclosure. It has built-in DI, DO, AI, RS-232, RS-485, Ethernet, SDI-12, and vibrate wiring interfaces. Low power 1 telecommunications ready. Further, a long-life rechargeable battery and built-in solar charger system are standard features. You do not need to customize a big and heavy chassis, do not need a well-trained engineer to wire between components. Install and maintenance IoT stations would be easier than ever, entire work can be done in few minutes. And, the most important is, you can deploy a huge number of IoT devices in a short time at competitive prices. Besides, Sense Mini equips with a camera to take and upload pictures to the cloud periodically. Today, the device has been widely deployed in many different sorts of IoT applications around Asia. Based on the architecture of Sense Mini, we also provide OEM and ODM services for any companies or users who want to IoT-lize their products. The backend cloud, SenseLink, is a comprehensive, ready-to-use IoT platform. Users get their sensors reading on the platform as soon as they power on the Sense Mini and complete the configuration on SenseLink. The entire setup can be done in 5 minutes. That enables our users to manage tons of sensors easily. Maybe you are worried that the data will be locked in SenseLink. Don't worry. SenseLink provides hundreds of open data APIs for developers. From basic raw data access to advanced data filtering and aggregation, all open data access features have been ready for our users. If you want to keep your data in your physical server room, no problem, we can help you to install SenseLink and complete all network, OS, and database settings. In the rest of the presentation, I will give you 2 practical cases to show how do we apply SenseLink plus Sense Mini solution to a flood management and smart irrigation system. In Taiwan, a typical flood management system must be consisted of 3 major parts, which are sensors, forecast model, and decision-making support system. The forecast model depicts the estimated inundation map based on the data collected from sensors and weather radar. And the decision-making support system generates suggested rescue teams and mobile pump deployment locations. In the Flood Disaster Control Center, the chief officer grasps clear, instant, and correct information from the system. The following slides show a simple scenario of how a chief officer grasps flood disaster information. The weather radar gives the high resolution of precipitation forecast. The rain gauges give the instant cumulative precipitation readings. The river water level stations provide canal and nature river water level instant readings. The urban surface water gauges provide instant flood information of a city. All the information gathered from those 4 different sensors, by helping with hydraulic models, we generate estimated inundation maps, which give us the predict flood area quantity. Based on the estimated inundation map, a property loss estimation and mobile pump deployment decision can be proposed by cloud system automatically. The inundation maps are not only crucial information during a flood disaster, but also a treasure for further applications, which can be the foundation of civil engineering, flood insurance, and financial derivatives designs. The second SenseLink Plus Sense Mini application is smart irrigation. We deploy thousands of sensors in irrigation canals and farmlands. The collected information is analyzed in SenseLink. SenseLink then gives the irrigation gate control decision to all the gates without human intervene. The dashboard shows instant information while an automatic irrigation robot doing its job. Users watch the video streaming of the canal, irrigation gates, and surroundings on the dashboard. We also provide a corresponding gate remote control user interface if a user wants to intervene in individual gate manually. There has been over 500 irrigation gates in Taiwan powered by ANA System automatic irrigation system in the next 5 years. The number of installation would be doubled. All the remote control gates equipped with an AI object detection wizard. If people hanging around in the hot zone are detected, the gate stops moving and notifies gate manager immediately. Enormous of IoT applications can be leveraged by SenseLink. Because of the limitation of time, we cannot share all of them. If you are interested in our solution or any further questions about the presentation, please feel free to contact us. Thanks for your attention. I hope we can have further business cooperation in near future.
Terima kasih Mr. Richard atas presentasi Anda. Selanjutnya, presentasi terakhir akan dibawakan oleh Mr. Dun dari Material and Chemical Research Laboratories, Industrial Technology Research Institute Taiwan, yang akan membahas mengenai sistem pengolahan air terdesentralisasi Q-Water. Mari kita sambut Mr. Dun.
Good afternoon, ladies and gentlemen. I'm Wei Zhejian from the ITRIS. So today we want to talk about the topic is decentralized water treatment systems. We call it Q-Water. So why do we want to innovate this kind of water treatment systems? Because according to the UN and WHO statistics, about 800 million people in the world, they can get the clean drinking waters. So cause every 2 minutes one child will die because they drink the unclean water. So how do we to improve in dissolve this problem? We want to start from the Q-Water. And in the beginning, the Q-Water is designed for the disease relief water treatment system. So in the 2009, the huge typhoon is Morak. They hit Taiwan and cause damage in the south of Taiwan. So we face on some problems. We cannot send the water treatment systems in a remote area. Then we can see the face on problem is the road is broken, the water quality is bad, and the long extension times. And in the disease area, we cannot get the power easily. So we try to think the key point we want to overcome is we need to decrease the system size and weight, and focus on the water quality is turbidity and bacteria, and how to easily extension the systems and to saving the more energy, or you can set up the green energy equipment. So we can see this chart is the what Q-Water evaluation. Since the 2009, the initial water treatment system is very big, and the size is over the 12 cubic meters. So in the new Q-Water and the Q-Water generation, we can overcome this problem to decrease the weight, the size weight less than 400 kilograms. And the area is only 1.3, 1.8 cubic meters. And the small area we can provide more than 5 or 10 cubic meters today is drinking water. And we can see this the first type, the Q-Water system. We have the 3 Q, so why we call it Q-Water. It's quickly, quality, and quantity. So we can see it's the general Q-Water's process. The first one is a cleaned plant. We want to remove the big particle and the mud and some sand. And the bionate is a PU sponge. We compress it and to like the sand filtration function, but it's very light, so it's easily to transport or to replace. The third one is UF membrane. It's a PVDF material. The pore size is only 0.08 micrometer. So we can know the bacteria is normally it's a 1 microliter. So this membrane can remove 99% the material, the microorganism. So and the last one is a UV, is to confirm the microgram is all eliminated in this system, so we can provide the safety drinking water. And the second type of Q water, we want to treat the more sea waters or some groundwaters. So we add the more material inside the RO membrane. You can choose the general RO and the seawater RO. So this Q water can treat more raw water to provide the drinking water. And in the topic, why we call the Q water is the decentralized system, because you can see the left picture. It's normally in the city or in the downtown, we want to set up the water plants to provide the drinking water for people, people in the city. But we need the complete water treatment process and the water network and some infrastructures. It's very expensive. So if in the remote area or the undeveloped area, the people maybe one village is just 200 residents, or the other village is very far away. So it is not easy to build the traditional water plant. So in this moment, maybe Q water can play the important role in the remote area because they can set up very quickly and provide a very good water quality. So now you can see since 2009, we set up the first one Q water in the remote elementary school. Until now, it's operate more than 9 years. And you can provide teachers or students drinking water. One day, it can provide 30 cubic meters. Yes, and one day, 1 cubic meters, they just need to consume 1 kilowatt. So it's very consumable for the power or some maintenance cost. So until now, you can see the 2011 and 2018 Taiwan, more than China, Europe, and the South India, they all have the Q water set art application. So maybe I can show some case study to share some experience for you. So you can see in Taiwan, we have some, maybe in the mountain, we compare about the green Q water. You can see the wind machine and the solar panel. It also can save the more energy with the Q water. So that one is a water sanitation case. It has a water plant. It's easily to set up in a remote village. So you can see you need to get a coin and get the water. So people get this money can pay the employer fee or some maintenance fee. So I think it's a good financial process in Taiwan or in another country. So this is in China, and you can see it's for the aqua pond or some farm, because in China, their water is very hard, so they need some water treatment systems to solve this problem. Yeah, it's also this case. And the special case is in Poland, yeah, in Europe. So it's a water plant. They also want to treat the remote areas water. So they buy 1 Q water from Taiwan. But if you want to sell the system to Europe, you need to get some CE certification. So we to apply the machinery and the low voltage, the certification in Europe. So now the system is also can sell to the Europe or some country. Okay, this is a South India case. You can see it's also to sell the water to the residents. Yeah, it can increase the working opportunity. And then it's difficult is this place, their power is not stable and the water quality is bad. So we also redesigned the Q-water water treatment process to solve this problem. You can see the right side is after the active carbon, and after the UF, you can see the water quality is a good improvement. Okay, so this chart is about Q-water specifications. You can see now we have the 3 types. Q-water is a different water production volume. The left side is 15 cubic meters per day. It's a traditional Q-water process. And in the middle, we add the RO. So it's a water production volume is a little decrease. It's 1 day provide 10 cubic meters. So if you want to treat the seawater, Q-water is also can do it. Yes, 1 day only the 5 cubic meters production. Or you can see the energy consumption or some operation costs and give you for the reference. And now we also want to make Q-water more smart. So we also use the IoT technology in the Q-water. So we can get the big data, and we can also remote control, remote monitor the Q-water to reduce the manpower fees or some operation cost. So you can see this is our E-trees control center. We can get more information in this website. It's about the operation status and the water quality or water production rate. So we also can remote control this. Okay, final, beside the Q-water, our team also good at the wastewater treatment technology. Maybe you can scan the QR code to get more information in this website, or you can directly contact us to discuss what you need. Okay, so wait for your call. Thank you.
Terima kasih Mr. Jen atas presentasi Anda. Presentasi ini menutup acara webinar kita pada hari ini. Sekali lagi kami ingatkan, Anda dapat mengirimkan pertanyaan Anda melalui QR Code yang tertera pada layar Anda. Para perwakilan perusahaan akan menjawab pertanyaan ini dalam beberapa hari ke depan. Hadirin sekalian, atas nama TAITRA saya mengucapkan terima kasih telah menonton webinar ini. Terima kasih atas partisipasi Anda dan sampai jumpa di acara webinar berikutnya.
In the face of a worldwide pandemic, Taiwan has actively lent a helping hand to the world. Taiwan Global Anti-COVID-19 Pavilion. In this website, we've created an anti-epidemic products and solution providers section, where you can find information about suppliers or any particular business solutions. This section will help you reach out to more than 2,000 Taiwanese companies who can aid in your fight against the pandemic. In these videos, companies and experts discuss the latest innovations to help combat the pandemic. In this section, we put at your disposal the contact information of 20 Taiwanese top medical institutions. We also inform you about the main strategies used in Taiwan to effectively control and stop the spread of the virus. So please be sure to bookmark and share this website. And remember to follow us on Facebook for our latest updates.